Hey everyone, today we're going to be learning how to take limits with rational functions. Let's begin. Okay, so let's take a look at this rational function right here. So we have the limit as x approaches 3 of f of x, and we define f of x to be x squared minus 5x plus 6, all that divided by 2x squared minus 14x plus 24. So again, with all limit problems, we should always try to plug in that limit value first thing, so that ends up being f of 3, which, if we plug everything in, we get 3 squared minus 5 times 3 plus 6, and all of that's going to be divided by 2 times 3 squared minus 14 times 3 plus 24. And then, when you do all the math here, you actually end up with a 0 divided by 0 situation, which is indeterminate if you recall. And whenever we have this indeterminate form, there's some kind of algebra or something that we have to do with the limit to actually find its value. So here, we said they're both polynomials, so let's try to maybe factor. And the first thing I notice is that all these have a common factor of 2. So let me kind of drag that 2 out of there. So I am taking the limit as x approaches 3 of x squared minus 5x plus 6 divided by 2 times x squared minus 7x plus 12. That's how the 2 factors out. And then also, I noticed that I can factor this quadratic equation here and this one as well. So we can end up with the limit as x approaches 3 of x minus 2 times x minus 3. That's how that top numerator factors. Then all that is going to be divided by 2 times, and this factors into x minus 3 and an x minus 4. And as you can see, very easily we can cancel out the x minus 3 factor, and then at that point we are simply left with the limit as x approaches 3 of x minus 2 divided by 2 times x minus 4. And just this 3 is supposed to be the limit 3. It's not associated with that 2 there. So then when we just plug in that 3, well, we end up with a 3 minus 2 divided by 2 times 3 minus 4. So that's a 1 divided by 2 times negative 1. And so ultimately, we just end up with a negative 1/2. And that ends up being our final answer. So remember, if you ever have a limit like this with a polynomial that isn't approaching infinity like our relative growth problems did before, just factor and see where that takes you. That just about wraps everything up. Thank you for watching and have yourself a great day.